In this lesson, we are going to look at how we can use a table of values to graph a relation. So what we're going to do is we're going to graph the following relation using the table of values and the points that are on them. So the first set of points is at negative 310. Now remember, the x-axis is the horizontal and the y-axis is the vertical. And so we always look at these as a set of ordered pairs. It's negative 310. So we move 3 to the left on the x and we go up 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we put a point. Second point is at negative 2, 8. So you move 2 on the left on the x, and then we go up 8, and we put a point. Negative 1, 6, we move 1 to the left on the x, and we go up 6, and we put a point. 0, 4, that means we do not move off of the y-axis. We don't move left or right, we simply go up 4, and we put our point. 1, 2 means move 1 to the right and up 2. 2, 0 means we move 2 to the right and we do not move up or down. And then 3, negative 2 is 3 to the right and 2 down. So we plotted each of the points. Now, do you think it makes sense to join these points and to make a straight line out of this? Well, yes, we can. It's not in any sort of a situation. So we don't know that it can only be discrete data, that they can only be whole number or integer numbers. When there's no situation to it, we can plot our points and we can join them with a line, and we can extend it because this pattern would continue. So we can put arrows on both ends. So is the relation linear? Well, all of the points, we were able to draw a straight line through it. So yes, it would be linear. The term oblique describes a line that is neither horizontal nor vertical. This would describe the graph in example 1. So if we go back here, this line was not horizontal. Horizontal is this. That's a horizontal line. And vertical is straight up and down. So this line in the example was neither horizontal nor vertical, so we call it an oblique line. An increasing relation is one in which the graph rises from left to right. So if you go to the leftmost point that you can see, it rises from left to right. And a decreasing relation is one in which it falls from left to right. So it goes down. This would describe the graph in example 1. If we go back and look, if we go from the left to the right, it is falling or going down. So that's a decreasing graph. A relation has the equation y equals negative 2 minus 3x. We want to graph this relation and then determine if it's increasing or decreasing. So here we have a line. There is no table of values, but we can create a table of values. So we're going to create an xy table. Now, it's a good idea to choose at least 3 points. If we only choose 2, there's a possibility that if you make an error in one of them, you won't know you've made an error because you can always draw a straight line between any 2 points. Whereas if you have 3 points and you make an error in one of them, you will see that it will not form a straight line. So a minimum of 3 points, many people suggest you choose 5 points. So either somewhere between 3 and 5 would be enough to graph this equation. The other thing is, because we're graphing it in a table, or in a graph here, and we would like to try our hardest to keep the numbers on the grid so that we can have our scales of 1, it's a good idea to try and pick something on the negative, something on the positive, and maybe 0. So if you're only choosing 3 values, maybe you choose negative 2, 0, positive 2, or negative 1, 0, positive 1, or negative 5, 0, positive 5. There really is no right or wrong answer. Technically, you could pick 100, 200, and 300, but it just means the scale on your graph is going to have to be a lot different. So when I say choosing points, we're choosing x values. And I like to choose a negative, 0, and a positive whenever possible. So I'm going to pick -2, 0, and 2. And the only reason I'm not going to choose -1, 0, and 1 in this case is because I'd like to spread out the numbers a little bit so that the graph, I can see it better. If I pick -1, 0, and 1, everything is going to be within that small region. So I'm just going to expand my points a little bit. So now what we do is we use substitution. I'm going to substitute -2 into the equation. And I'm going to solve for y. So I'm going to put -2 into x, and then we're going to solve this. So if we do the multiplication first, -3 times -2 is +6, and -2 plus 6 is 4. So my matching y value in our table is 4. Now I'm going to do the same thing with 0. So we put 0 into the x spot. -3 times 0 is just 0. So -2 subtract 0 is -2. And then we do it again with +2. -3 times 2 is -6, and -2 subtract 6 is -8. Now we could check to make sure that we have done this right before we even plot. Remember, we're going to have a linear relation because it's the equation of a line. I chose consistent increments here. So if I chose consistent increments here, I should have consistent increments in this one. And if I go from 4 to -2, I've subtracted 6. -2 to -8, I've also subtracted 6. So it looks like I've got some good points. So now I'm going to plot these. -2, 4. So that means move 2 to the left from the origin and go up 4. And I put a point. 0, -2. That means I do not move left or right off the origin, but I go down 2. 2, -8. 2 to the right, down 8. And I put a point. And now because it was an equation of a line, we do need to join these. And extend, because this graph, we just happen to pick -2, 0, and +2, but it will continue that pattern in both directions. So we have graphed this equation. And now we need to ask ourselves, is this relation increasing or decreasing? Well, remember, we always move from left to right, and from left to right, it is falling. So this is a decreasing relation. One more for today. Graph the linear relation y equals 3x minus 4. So again, we need to create a table of values with a minimum of 3 points. You could go up to 5. Again, good idea to pick something on the negative, something on the positive. So again, this time, we'll stick with our -2, 0, and +2. Again, you could pick different values. So we are going to substitute -2 into the x. 3 times -2 is -6. And -6 subtract 4 is -10. Now I'm going to put my 0 in. 3 times 0, subtract 4. So we are going to get 3 times 0 is 0. 0 subtract 4 is -4. And then we put in +2. 3 times 2 is 6. 6 subtract 4 is 2. So we have our coordinates. -2, -10 means move 2 to the left and 10 down and put our point. 0, -4, do not move left or right, simply go down 4. And 2, 2 means move 2 to the right and 2 up. And then we are going to join these points and extend. And we can put arrows on the ends. So now, as we move from left to right, you see that it is increasing, it's going up, it's rising. So we call this an increasing relation. So just to review, when you have an equation, and there's no situation, we're going to be able to join the points. You create a table of values and you need a minimum of 3 points to graph. So you choose 3 different x values. Technically, you can choose any x value you want. However, keeping one negative, one zero, one positive, and fairly close to 0 will likely keep you within your grid so that you can use scales of 1. And then an increasing graph as you read it left to right goes up, and a decreasing graph as you read it left to right goes down.